that we need to really realize is that we have got 85.4% of dams which are earth dams or rockfill dams. This is a very major challenge from the dam safety management point of view. The flood handling capacity of the dam is quite crucial in order to avoid the potential failure of any of these dams. Most of the dams that in our country, whatever dams that have failed, many of the dams have basically failed because of the overtopping due to floods, and overtopping leads to sudden washing away of the embankment and creates a big disaster. The Machu 2 disaster, which was referred to earlier, has been one of the leading kind of a phenomena where we could see that the inadequate spillway capacity could lead to a kind of disaster which was kind of unprecedented, and we do not wish it to have any successors. So from that angle, we need to be very careful about the floods that our dams are going to handle and the manner in which these floods are going to be handled. If we do not do this well, then the dam safety management will always lack in our hazard preparedness. We started out, in fact, the Machu 2 dam failure was one of the major triggers. And in 1980, the State Irrigation Ministers Conference resolved that we would like to have a dam safety establishment in the country, and Central Water Commission started with it in 1980-81. And gradually it has grown. We have been able to persuade almost every of the states to have their own dam safety organizations, to establish the procedures and carry out the various activities. But still, the amount of activities that we have to carry out is something that is very, very, requires a lot of improvements in the. We have great challenges when it comes to the dam safety management. Because when you are designing a new dam, you are able to create certain kind of idealizations. And with those idealizations, you are able to assume that the behavior of the dam will be in a particular direction, in a particular manner. But then when a dam actually comes into existence and starts behaving in interaction with its foundations, in interaction with its abutments, and the reservoir interacts with the hydrology of the basin, then the whole new area of the operations and whole new area of concerns begin. And these concerns have to have a very sound footing on the hydrologic and seismologic environments. What kind of environment is developing? Because we made certain assumptions. We thought that it will behave in certain way, but now that it is behaving in a different way, what do you do about it? Like long time geotechnical behavior of the constituent materials. These issues lead us to a very great kind of a problem and challenge that we need to address. We have the socio-economic challenges for the dam, like recognition of dams and storage as hazards for dam safety for the population. This issue needs to be understood well, especially at the land and development planners across the country. Because when we construct a dam in a water-short country like ours, many of the years will be very, very water-short. And in initial, we will be using these waters very, very efficiently. So in the process, the downstream channel will become available for development, because for 5 years, 10 years, there will not be much of a flood. And people will try to encroach into the river. And then when you have to start planning for the emergency action program, and when you have to consider the releasing the waters from the dam, then you have a lot of constraints. For example, the imposition of operational constraints in many of the dams will actually effectively reduce their spillway capacity from what was designed down to somewhere around sometimes 1/4. And then also there will be bickerings. Many of the people like me who remained in the dam operations area will realize that in one of the areas where I was working, and we started out with a fact that we will be able to release about 250,000 cusecs in the channel at any given point of time, provided we give about 24 hours warning. This was what the planning was. And the situation is that when I was in charge, releasing 100,000 cusecs invited phone calls all the way from the chief minister of that state to the central ministry, and I was kind of being made to say that, look, you are creating a disaster. Whereas the flood that was coming in my reservoir was somewhere around 900,000 cusecs. So, and then recently, when I was almost at the point of retirement, like say 2015, and at that time, somebody was trying to release only 100,000 cusecs, and he was kind of constrained and forced to reduce it to somewhere around 80,000 cusecs. Now, this kind of operational constraints that come, it creates a huge challenge to the dam safety, because when you have to ensure dam safety, you have to take into account the socio-economic challenge that is going to be faced by the dam operator when he indeed implements that particular program. Because there may be constraints beyond his control which will prevent him from doing certain things. So this area is something which I feel that we need to really address very, very seriously. The other issue is that when you have built a dam, which may be for flood control, and then and the conservation use becomes more and more important, and then you will be forced to keep your reservoir at a higher and higher level in order to see that more and more water remains available within the reservoir, and even if the monsoon fails, you will still have that water, kind of an insurance against the food safety. And that higher level may lead to a problem when you actually try to handle the dam in a really a historical kind of a flood. This challenge is something that we have to address very systematically. The dam safety in our country, we still try to, like, you would have seen in the inaugural session. I have a basic problem with the way we are trying to propagate the dam safety. The dam safety propagation is happening in the context of failures. Failures are, of course, very important and very valuable incidents, very unfortunate incidents also, but equally technically very valuable incidents. But the fact remains is that the dam safety has to be viewed in the area of the portfolio risk management. It should be viewed towards your asset management discipline more than the association more and more with the failures. Because what happens is that when you keep on associating it with the failure, it's like trying to create some kind of a demon or some kind of a Frankenstein, and trying to all the time kind of keep on making the people afraid, so that they will be interested in doing certain things. But I feel that what's more important is not necessarily that, but these are your assets and you have to manage them well. And if you have to manage them well, how do you manage them well? This is something that we need to really understand. What I find is that another issue, because my time is rather limited, I would make one more assessment, one more stipulation, that we need to have standards for dam safety assurance. Over the period of time when we have been interacting with the dam engineers, most of the time when we come to the dam safety, we have a issue. We try to compare it with the design standards, and in many cases we are finding that the design standards that are there are based on certain idealizations, and those idealizations are not adequate when you have to actually assess the existing safety of the dam in the context of the present prevailing circumstances and the technology. One of the very, close to my heart kind of problem is the seismic stability of, let us say, concrete or masonry dams, where you try to use the new approaches for the site-specific risk assessment, because now you have a dam, it is existing there, you have got the data about it, and you try to use the theories which actually do not recognize any of the mitigating factors, like the elastic behavior of the dam and foundations, the capacity of the dam to absorb certain kind of energies, seismic energies. And because of that, the problem that happens is that we need to really have the standards which are oriented for understanding the behavior of the dam as it exists today, and then try to incorporate them in our safety envelope, so that we are in a position to properly manage our dams in a safe and sound manner. So from that angle, I feel that we need to really start looking at these areas more and more closely. Another issue is that of the capacity building. The capacity of a dam operator to handle the flood which comes in the form of PMF or maybe SPF is very limited. We have got population around and we have our people, we keep on getting transferred time and again. And in the process, there is no guarantee that a person who will be at the site will have the capacity to handle that kind of a flood if and when it occurs at his site. So from this angle, I feel that the capacity building of the dam operators is very much essential. Simultaneously, the capacity of the designers and planners in the use of modern tools and making assessments and judgments out of the modern tools is another area of concern where also I feel that we need to really do a lot of capacity building. So from these angles, I feel that we have got very huge challenges in the safety evaluation of the dam, and I feel that we need to really address this through a systematic adoption of debates, systematic adoption of examination, dispassionate examination of various phenomena that we are encountering time and again, and coming up with a solid knowledge base on which we can base our recommendations and we can base our assumptions. So from this angle, I feel that we need to really work very hard in the dam safety management area, and we need to change our focus towards the asset management. We need to change our focus towards the documentation that is required, and we need to change our focus on the capacities that are going to be required in order to see that our population of dams remains safe. They keep on delivering the benefits that they are delivering today, and these benefits are going to be more and more valuable if we have to maintain the food security for an ever-growing population, which is still not showing any sign of kind of delay. Thank you very much. Thanks a lot.
Thank you, Mr. Pandya, for a very interesting and exhaustive presentation on the dam safety management in India. You almost covered almost all the points in this regard. I think what we can do, we can have the presentations first, and then we can have a joint question answer session. So I would now request Professor Dr. Anton Schles, President of International Commission of Large Dams, ICOLD, for making his presentation on sustainable and safe development of dams and water sources as vital infrastructure in this century. May I request Dr. Anton to make his presentation in about 20-25 minutes.
Ladies and gentlemen, it's a pleasure to share with you some thoughts on sustainable and safe development of dams and reservoir as vital water infrastructure in this century. So here you see a little bit the aspects that I will talking about. I will start first with water infrastructure and the hydraulic schemes in the world, and then say something about economic prosperity, thanks dams and reservoirs. Then a little bit have a look on the worldwide importance of development of dams and reservoirs. I will also speak briefly on dam safety concept, and then how we have to design today dams so that they are successful, and finally talk a little bit about climate change. As you know, man has used since more than 1,000 years water as a vital element, but he also tried to protect him always against the water as a destructive element. And you see the use of water, of course, water supply, irrigation, hydropower and navigation, but you see also protection against water. Okay, if we have polluted water, we have to make a sewage treatment, but of course drainage, flood protection and protection against erosion, these are the issues, the protection against water. I think you are aware, especially here in India, that irrigation is a very important aspect. So you may know that 72% of the global water withdrawals are used for irrigation, and this irrigation produces today more than 650 million tons per year of cereals, and irrigation allows 40% of food production in the world. And what is much more important, only on 7% of the arable land. So you see, irrigation is really important, and since 1950, almost 80% of the growth of the world food production was directly related to the improvement of irrigation. Without irrigation, we could not survive in this world. And you know also that still 2/3 of the world population is suffering of the lack of safe water. Safe water means enough quantity, but also enough quality. And you know also that 1 billion of the world population is still threatened with famine, and this can be only overcome by food production, which is increased by irrigation, by using reservoirs, of course also water and transfer system restitution structures. Another aspect of the use of water is navigation. We have to be aware that most of the goods exchange and their transportation in the world is ensured by sea and river navigation. Now comes to hydropower. Hydropower is very important worldwide. You see it contributes today to 17% of the electricity production. And you see also 11% is nuclear, 5% until today is wind and solar. But what is very alarming in view of climate change, that still 40% of the electricity is produced by coal, and 23% of natural gas and 4% of oil. You see here a very nice dam. I thought to have a little bit more of your attention. I make a competition on the top dams in Kerala. So I will present you 6 top dams in Kerala. And the person who will send me until tonight an email naming all these top dams, recognition in Kerala, will get a very nice box of Swiss chocolate. So be careful, this is Kerala Dam number 1. And I hope I get a lot of emails until this evening. And tomorrow morning I will bring this very nice box of chocolate, of Swiss chocolate here. Okay. Kerala Dam number 1. So let's go back to hydropower potential. Of course, if you look on the whole world, then only about 42% of the hydropower potential is used. On the right, you see India. It's perhaps 30%, 1/3, which is used. You see also that high potential is still available in Asia and, of course, in South America. But the largest potential there, which is still can be used, is you can find in Africa, where only about 12% is used. So you see, in this century, I'm convinced that hydropower will and has to have a bright future for, of course, electricity production, renewable electricity production. Another problem is, of course, hydraulic structure, or let's say water infrastructure, have to protect against water, mainly flood protection. But, of course, today we have also a lot of problem with soil erosion and droughts. So finally, just in this short introduction, I think the major problem of the world population in this century is without doubt the supply of ecological and renewable energy, and also the supply of water of good quality and sufficient quantity. And of course, we have to fight against famine, poverty, and disease. And of course, there is a lot of political will. So we know, for example, there is the Nexus approach, which should, in this century, improve water, energy, and food security on a global level. Also, the United Nations, they made an Agenda 2030, saying that we have to have sustainable development goals, and there are in total 16 sustainable development goals, and 6 of these goals are directly related to sustainable development of dams and reservoirs. For example, goal number 2, Also goal number 7, then goal number 8, I do not read them, you can see it yourself, goal number 9, and finally goal number 13, where is related to climate change. And ICOLD is already active since a long time, and in 2012 we already initiated the World Declaration on Water Storage for Sustainable Development, which goes in line with these Sustainable Development Goals. So in this century, we have to overcome this challenge, and to overcome it, we need investment in the development of new water infrastructures as reservoirs and dams, as well as their maintenance and refurbishment in order to ensure long-term safety and economic prosperity everywhere. So you see here is competition number 2 and 3. I hope you recognize these nice dams in Kerala, so please memorize them. So we know that in the past economic prosperity a little bit all over the world was ensured thanks dams and reservoirs. And dams and reservoirs are really key water infrastructure for the use of water, as I have shown you, but also for the protection of water. And the history shows that the economic prosperity of society, of any society and its cultural wealth was always closely related to the level of the development of water infrastructure, including dams and reservoirs. I have just here very fast an example which I like to present very often. It's a dam in Marib in Yemen, the dam Marib in Yemen. So it has, the construction of it has started 519 BC, and it was constructed during the Kingdom of Saba, and it was already an astonishing reservoir for 30 million cubic meter, which allowed to store 15% of the runoff. And this was the economical basis of this Kingdom of Saba, providing water for irrigation for about 110 square kilometer agricultural land. And you know very well from the written historical documents that it was used for trading of food, but also as spices and aromatics such as frankincense and myrrh. And this dam was completed also with an amazing irrigation system with 2 large tunnels, and this dam ensured more than 1,300 years the success of this kingdom. And it was the largest infrastructure which was built in the ancient time. So only after 1,300 years this dam failed, and probably it failed due to a large flood, but also probably due to neglected maintenance. And of course, also an important topic which we discussed in this conference is safety, and you see maintenance is really very important to ensure the sustainable use of this large infrastructure, even if we don't ask to use our dam more than 1,300 years, but I think they will be still in the environment. So this failure of this dam resulted in an economic disaster in this region. So again, I can say that the prosperity of any society was and will be strongly linked to the quality of water infrastructure. So now let's see what we have in the world. We have almost 60,000 dams today, which are higher than 15 meters. India, okay, I saw the last number is 5,102 dams, large dams, which are in the register, and you see also the 100 largest reservoir in the world. These reservoirs, they can make available 4,000 cubic meter of water every year. What is 4,000 cubic meter of water? It's really very important. If you make a snapshot today, at this moment, you find 2,000 square kilometer of water in all rivers. And you see what is stored in the dams is the double. So that's really very important to bring water from dry periods to wet periods to dry periods. We see also dam construction since 2000. You see in yellow the dams higher than 60 meters. You see the dams the very high dams, 150 meter, and you see the construction is almost constant. You see a little bit, a very slight oscillation of about 10 years, but we have always about 350 to 400 dams higher than 60 meter in construction, and 40 to 50 dams higher than 150 meter under construction. Ladies and gentlemen, that confirms that dams are vital infrastructure projects which are not really influenced by economic crisis in the world, because on this graph you don't see the 2 or 3 economic crises we have, because these dams have to be built all the time because they, I repeat, they are vital infrastructure. And here you see where the dams have been commissioned over the last 18 years, since 2000. And what you see, it's a kind of a horizontal band where these dams have been built. Okay, it starts from the United States. You don't see there a lot of activities, but you have to be aware that there are several thousand of dams have been built in the last century. And this region in the United States is one of the largest crop growing region in the world, which ensures a lot of food safety in the world. But then when we go to Europe and then we go to the Middle East, these are locations where you have semi-arid and arid climate. And this is also the regions which are already touched most today by climate change. So there they need urgently dams and reservoirs, and therefore this is an ongoing activity since 2000. And then we go to Asia. Asia is, of course, is a monsoon-triggered region. It's also a very populated region, and you see also there is a high need of dam construction and reservoirs. And I could call this band horizontal band. It's a kind of a security belt around the world to ensure water, food and energy. And it's not for the pleasure of the engineers that the dams have been built along this belt. It's just to ensure this safety of water, food and energy. There is also activity towards the south. You see there is quite a little bit activity in South America. There is a little activity only in Africa. What does it mean? We have a huge problem in this world, which is the huge economical gap between the north and south. And therefore, it's very important that also in the south, this water infrastructure will be built in this century, and this confirms also what is ongoing at the moment, because there we need new reservoir. And especially, I think this century will be the development of Africa, and if we do not succeed to develop also the south part of our world, then we will have a lot of problems this century. Okay, you see India, there is, of course, still quite a high hydro potential, perhaps 30% is only used. I have just seen in the register 154 dams are higher than 50 meter and 59 dams are higher than 100 meter. So for India it's also important to develop further in this century water infrastructure, especially dams and reservoir. I had also a look what are the high dams under construction higher than 60 meter in India since 20 years. And you see, unfortunately, there is a little bit decrease of the activities. So you see it over this about 20 years, but I'm always very positive. So there, everywhere in the world there are some ondulation, and I think the ondulation in India is about 20 years. So therefore, it will go up from the next year. And I'm convinced, and also the activity shows that it's already going in this direction. So hydropower is still under a liberalized market condition, the cheapest and the most flexible renewable energy. And in the world we have used only a little part of this hydropower. And as I already said, water infrastructure are important for ensure safe water beside safe energy in this century. Okay, so our challenge in this century is to satisfy the vital needs of the world society, which is water, energy and food. And of course, we have to do these large water infrastructures as dams and reservoirs with respect of environment. Please be careful. So this is question number 6. This is the number 6 dam in Kerala. Sometimes we are talking a little bit on dams and reservoir a little bit on the negative side, but I just want to say, if we compare hydropower, for example, with other energy produced, if we are looking on a recovery or gain factor of primary energy, so if you plant a hydropower plant, so you need some energy for the construction, you need also some energy, of course, indirect for the material, but what you get out is much more what you inject. So I just show you here that, for example, for a high-head storage power plant, which normally you can operate without any problem 80 years, you get out the energy 280 times. You get out also for a low-head run of river power plant, the energy invested, you get out it 175 times. If you are looking on small wind power plants, okay, the technical life is said to be about 15 years, you get out it only 30 times. Small photovoltaic installation or a photovoltaic power plant, okay, perhaps a lifetime of 30 years, you get it out only 6 or even 3 times. Of course, the technology will be improved, but ladies and gentlemen, we have to see also this sustainable development. So dams and reservoirs, they have a very big trade-off compared to the invested energy. Also, when we are looking on CO2 gas emissions, for example, we made a study in Switzerland, run-of-river power plants, they produce 3.6 grams per kilowatt hour produced, or storage power plant a little bit more, up to 10.7 grams. Of course, nuclear power plants in this way are also quite favorable. If you go to wind energy, if you count everything which you need for producing a wind power plant, so you have 70 grams per kilowatt hour, solar energy 80 grams, biogas 77 grams, and of course if you go to coal-fired power plants, then the numbers increase considerably. Coal-fired plants, you see more than 1,000 grams per kilowatt hour. Okay, ladies and gentlemen, I think a large water infrastructure project can provoke worldwide controversial discussions. There is a lot of, let's say, opposition on this large infrastructure project. I think when we are looking on this large infrastructure project, we can say that no dams is not an alternative. No dams means no water, no food, no energy, no developments, no future for the young generation. I think the only alternative is better dams for a better world, and therefore we are sitting all in this conference, ladies and gentlemen. Okay, if we are designing new dams and reservoirs today, I think the world has become very complex, and we can overcome this challenge only if we are planning water infrastructure with a global approach. We need a wide acceptance, and this wide acceptance can be achieved in the framework of a multi-purpose project, which can create a win-win situation for all stakeholders. That means that we have the simultaneous satisfaction of several goals, as, of course, energy production by hydropower, irrigation, drinking water supply, food protection, improvement of flow regime, creation of biotopes and natural reserve, as well as touristic attraction, as we see also with these nice dams here in this state. They have become a lot, most of them, a touristic attraction. And of course, multi-purpose projects are complex systems, and besides sound technical knowledge, also a comprehensive system engineering competence is required in order to treat correctly these complex projects. So ICOLD helps the profession in setting standards and guidelines to ensure that dams are built and operated safely, efficiently, and economically, and are, of course, also environmentally sustainable and socially equitable. So today we have about 20,000 individual members, 100 member countries. We are very happy that we could welcome last year our 100th member. You see here this very nice map of the logo of ICOLT. I don't know if you find India inside. Of course, as president of ICOLT, coming from Switzerland, you see where Switzerland is. Switzerland is on the top of the dam. So I would say Switzerland is not really under pressure, so we are on the top. So, but I don't know if you have found India. Okay, India is almost on the foundation of the dam, so India is a little bit more under pressure. But ladies and gentlemen, of course, India is much more important than Switzerland because, you know, the foundation of a dam is the most important thing. So these are the 3 countries which we could welcome last year, and we are especially happy that Bhutan joined ICOLT as a 100th country. Also, Bhutan has the politics of GR of happiness, and therefore we are really happy that Bhutan changed ICOLT. And we know also that India is a lot contributing to the development of hydropower in Bhutan. So ICOLT, we have at the moment 31 technical committees, and I say always these committees are really important for us because they contribute really to the overall goal, which is better dams for a better world. And we are also thinking that's really important that we have a high support for the young dam engineers, and we are supporting actively this young engineer in order to ensure future excellence in the worldwide design and construction and operation of water infrastructure. Some words on safety, which is, let's say, the topic of this conference. I think any dam safety concept has to be, as we have it, for example, in Switzerland since a long time, but in many other countries, has to be based on 3 pillars, which is structural safety, which is achieved by appropriate design. With structural safety, we have to minimize the risk, but on the other side, we need 2 other pillars, which is monitoring and maintenance and emergency concept. So monitoring, maintenance, we have to do the dedicated checks, and we have also to be prepared in any for emergency, which could also occur even with a very small safety probability. Of course, structural safety for any hazard for a dam is important, and this is the task of engineer to design the dams that they are safe for any hazard, and it's very often done in a deterministic way. But of course, we need also monitoring and maintenance. The purpose is to detect any structural defect early so that we can take actions, and it's, we have to do the necessary measurement data, obtain the measurement data, and also to check regularly the behavior of the dam, and we can then, with this measurement data, have an idea how the dam behaves and how the dam will behave in future. But we have to be prepared also for the worst case. We never know if there something can happen, and we have, based on the identification of the threats, we have to take protection measure. On the other side, we have to install a warning system, mainly in regions which are, let's say, there is a high risk of, in the case of a failure of a dam. Today, we use very often risk analysis as a diagnostic tool. I could participate with my research team to a European research project which was dealing with critical infrastructure and to see how they react against natural hazard. And of course, dams and reservoirs are critical infrastructures, and the goal was to recommend in Europe a kind of stress test for this critical infrastructure and to analyze how they behave towards hazard, but also towards multiple hazards, which is important. And then we have to come up with a risk estimation, losses per year. And then, of course, for such analysis, the key aspects, or let's say the scientific challenges, are using, as for example, Monte Carlo, which are a very flexible approach. Also, we have to have algorithms which are efficient because we have to make a lot of simulation. And what is important that we cannot have only a look on the dam, we have to look the dam as a system in his environment because we can have cascading effects. For example, on the graph you see a simulation of a flood wave, and you see on the right side the probability that the 3-store concrete house will be destroyed from 0 to 100%. So these are things which we can do today as a diagnostic.
Kindly conclude. You have a minute or two more.
Okay. So I'm almost at the end. I'm just talk a little bit on climate change. Ladies and gentlemen, I hope you are aware that new dams and reservoirs will be required and are vital in many regions in order to mitigate climate change. I showed you this graph where the dams have been built over the last 20 years, and they are mostly have been built in regions where they fear and they feel already a lot today climate change. So the dams are a kind of mitigation measure. They allow to accumulate the perturbed water resources regime and to ensure water, energy and food, as well as to protect against climate change. If we are talking of climate change, something which is a large danger for our reservoirs is reservoir sedimentation. I think reservoir sedimentation is the big brother of climate change, because with climate change, sediment yield will increase into our reservoir, and it's absolutely important that we have new tools, that we have new approaches to deal with this reservoir sedimentation. But climate change has also opportunities. For example, in Switzerland, we have glaciers which are retreating, so they are freeing new valleys, and in these new valleys, there are some parts of the glacier which is remaining. This glacier can break down normally into lakes which have been created in the forefront of the glaciers. So this breakdown of the glaciers can be really very dangerous. And therefore, we started to plan new dams, not only against this natural hazard, but of course they will be used also for hydropower. And this is, for example, a project which has been just given to the authorities for approval. So it's a new 180-meter high dam, which is using a natural lake which has been created by glacier retreat. I think in the Himalayan region we have a lot of such new valleys which will be created. We have a lot of new lakes which will be created, which are very dangerous. And I think this is also an opportunity in this region to have further dam development higher in the mountains in the Himalayan region. Okay, ladies and gentlemen, I'm just come to the conclusions. I would say again, I think that's a little bit my last tweet. Again, you know already this tweet, better dams for a better world. Perhaps another president would send another tweet, dams first. I would say I send another tweet, dam safety first. Thank you very much and have a nice conference.
Thank you, Dr. Anton Schles, for a very illuminating presentation. Why dams are necessary and why they are essential for economy and for the prosperity of the society at large. Now I would request Mr. Satoru Ueda, lead dam management specialist, World Bank, to make his presentation on regulatory framework for dam safety, World Bank perspective. May I request you to kindly restrict it to about some 15 to 18 minutes?
Thank you very much. So I'm going to talk about the regulatory framework for dam safety from World Bank perspective. And as I earlier introduced, the World Bank has been providing quite a lot of financing and technical assistance to many countries, but still compared to the needs and actual dam construction projects, our intervention is quite limited. So we firmly believe it's very important for us to work with the countries to help them develop the dam safety framework. Now, through our experience, we've seen this typical challenges for enhancing dam safety, and such as this complicated institutional relationships and the legal definition of dam safety, therefore owners and developers and the regulators and so forth, and then also a lack of national dams classification system, or the insufficient implementation and enforcement capacity of the regulators, and so forth. We have been conducting a global dam safety study with the focus on the legal and institutional aspects, and having conducted the 51 countries case studies. We are currently at the finalization status. They're having checked their case studies and so forth. So these are the key subjects that we have covered, and the legal and institutional aspect. We also look into the content of the regulatory regime, and also as we studied about the recent trend of least informed approach and emergency preparedness, financing aspects, and so forth. We are building on the previous efforts by ourselves, and the bulletin, the guidelines they issued in 2002, and also refer to a number of very important ICODE bulletins, and also this regional club of the ICODE. And these maps indicate countries which have picked up for case studies, covering different parts of the world, different levels of economic development, and so forth. Now, I'm going to introduce substance about our studies, the first legal aspects, and for dam safety responsibility and the legislation. This map shows the type of legislation. Red indicates common law, and blue indicates civil laws, and so forth. I'm not a legal specialist, but our legal expert advised that it's very important for us to first check what the legal system adopts. Because in the end, we have to follow this legal system, whatever this dam safety regulations, the laws are to be established. And then also, this one important thing we found is this: about 1/3 of the countries have not legislated particular laws covering dam safety, either in the water resources, disaster management, and the natural resources, and so forth. And most of them are in the low and the middle income countries. It's quite important that the regulatory frameworks should define the roles and the responsibilities of the owners, operators, and regulators, and so forth. But there are different ways to legislate that. And as I mentioned, there's some established, legislated, dedicated dam safety law. Others included the dam safety provision under the water law, or environmental law, and so forth. And also, we have different countries which adopt their common law, and typically this system sets out the principle of dam safety, but defers the more detailed regulations to the guidelines, which are not necessarily under this dam safety legislation. But in the case of civil law countries, they typically prescribe quite detailed codes about their design standards and the regulation and so forth. So there are pros and the cons, and again, but we have to follow the system. And another important, interesting thing is the institutional setup. For example, some countries have more centralized their system, others have more federal, state government systems. So in the case of countries which have this federal system, they do not allow the central government to prescribe the national level dam safety, but rather just to defer to the state and provincial level, such as in Canada and in Australia. It's important again to define the roles between the key players, owner, non-owner, operator, and the regulator, but we have to look at the institutional arrangements, and the different countries have different arrangements, but based on the studies, what we found is that many countries have independent dam safety authorities. One way or another, some countries have established dedicated dam safety agencies, and the others have more their independent approach, and then also other countries have mixed approach depending on the sectors. And but I think we find it's quite useful to ensure this independent oversight mechanism over the various kind of dams. And in the case of self-regulatory system, at least there is some review mechanism, such as use of this independent commission or review committee has been used, and it is certainly recommended. This slide gives you some flavor about the different type of approach and depending on countries. Some countries, European countries, have adopted cross-sectoral regulation. There's some type on the basin level. They conduct the dam safety checking. Other countries have a completely parallel system. For example, in China, they have a system dedicated for water resources irrigation sector versus hydropower sector. Even this, they have their own this dam safety and inspection agencies. And some countries have the independent check-in regulatory agency for particular sectors, such as of hydropower in the US by FERC and so forth. And then also that the Brazil has recently established this more a comprehensive regulatory framework in coordination with this sectoral regulatory agency for hydropower, mining, and then water supply and so forth. And then there's, again, self-regulation models could work, but depending on the specific provision and the capacity. I mean, U.S. federal agency have developed their system and the capacity, while the other countries' self-regulation system seem to be quite weak. I have already talked about the Brazil state, so I will go through it. And now if we go into the further detail about the level or depth of this regulator, the check-in, there are different models. Some countries have regulator do this more compliance audit, reviewing this submitted inspection reports by the owners without going in detail. On the other hand, some other agencies, the governments, have regulatory agencies which will go into more direct surveillance and checking. And of course, these arrangements can be useful depending on this capacity of the regulator versus the owner, or this financial capacity to support the ownerless regulatory system and so forth. And then also there's the type and the size of portfolio. And of course, if you have limited the number of dams for particular sectors, you don't want to develop such an ownerless system. But on the other hand, if you have quite a number of major dams in the same basin for different sectors, you may want to see this comprehensive dam safety at the regulation authority. I think I have covered the key messages. I think as the dam owners be clearly responsible for safety of the dam and the operation of dam. Regulators are responsible for setting design standards, standard of care, and monitoring and compliance requirements and so forth. But depending on the governance system of different countries and also portfolio, there are different options to choose a suitable regulatory mechanism. And I think, as I mentioned, we need to also look at this size and the complexity of portfolio in addition to the governance system. Now I come to the content of the regulatory system. Among many elements of the regulatory regime, there are quite a number of countries that have adopted dams classification system, which we found quite useful. There's the classification system to define the required design standards or safety requirements, such as inspection frequency and reporting and so forth, based on the structural risk or dam's dimension, the downstream hazard, potential consequence, or in a combined manner. And design standards are typically linked with this the dam classification, as well show some examples in the following slides. But also that's I'm going to talk about the risk management, the risk-informed decision-making, how this new approach as a supplement in this deterministic design standard-based approach. This is the result of studies. As you see, some countries have used the classification based on size only, which are the height and the capacity, which could be a good proxies to indicate the hydraulic force or the impact of flooding in case of dam failure. And other countries look at more just the downstream, their conditions and hazard level, and then also combined one and so forth. I take an example from Ontario, Canada, as a case for hazard-based classification, and they just use this the downstream hazard potential from low to verified in 4 categories, looking at the life safety, economic loss, and then also environmental and the cultural heritage and impact in case of dam failure. You see this, they put their specific threshold numbers for the life safety at 10 people and more than 10 people, which are generally quite low because, as you know, it's quite tricky to indicate particular thresholds of the potential life loss. But I think this example gives a comprehensive picture of different elements to determine the downstream hazard level. And this system determines or just recommends the level of the inflow design flaws based on this life safety and other elements. And also this systems define the required level of dam safety assessment, inspection frequency, mechanical equipment testing, and so forth. So this system is quite useful in defining this requirements of dam safety to the owners and the operators. Now I take another example from France. This classification system is based on dam the size. As you see, the classification criteria is based on height and the reservoir capacity. They produced some a bit sophisticated formula to indicate the level of their this hydraulic impact. But also they developed this inflow design flood depending on the type of dams, concrete dams and embankment dams, and of course, we need to be more careful about the embankment dam safety, potential overtopping, and so forth. And in addition to inflow design flood, they also indicate a safety check flood, and in addition to design standard, they also stipulate the required safety requirements, monitoring system, the safety inspection report, from category A to category D dam. One of the interesting things is that they require the risk assessment for category A and B dams. So this is one of the, I think, a few cases that really they officialize this requirement of the safety requirement for high hazard cases. Now we have a look at the different cases and presents a percentage of what percentage of regulatory authorities are endowed to some specific functions, such as develop norms and standards, issue permits, and conduct inspection, and so forth. And some countries, they have particularly indicates the research and the development in the regulatory framework. This slide shows the way of performance monitoring and measurement. Indeed, we have tested this in dam safety project in Indonesia, and we have introduced some benchmarking mechanism for multi-dams, their safety compliance such as this, the submission of timely inspection reports, or this sufficient execution of required remedial works, or this periodic consultation with stakeholders for their emergency preparedness and so forth. And so we prepared this graph for different basin organizations, and we think that that are also a good ways to stimulate this interest or commitment from the basin organizations to do the better work for the dam safety. And some countries, there's some, such as Brazil or also USA, requires the agency to submit the overall the dam safety records. And Brazil just submit this annual dam safety report to the Congress, and the US under the FEMA to submit the biannual report. So this is also an important ways to enhance this, dam safety requirements, including monitoring and reporting. Now I have come to another subject in connection with this dam safety regulation. I think it's risk-informed dam safety management is becoming common in many countries, and I think it is quite useful when it comes to rehabilitation or safety improvement of existing dams. As I showed earlier, we have been financing quite a number of dam rehabilitation projects, even on the national scale. And so it's quite important to have some standardized, consistent measure to discuss and agree on which dams should be rehabilitated first and which should come in the more later stage. So this portfolio risk assessment and management technique is quite useful to give some useful tool to this, identify this.
Mr. Oida, you have two more minutes. Kindly conclude.
Okay. And then also we have used this potential failure modes for quite an important dam, such as Nurek Dam in Tajikistan. So we found that these techniques are quite important. And we have also conducted some studies of which countries have this encouraged or even mandated this risk-informed dam safety management. And so we have also collected some good examples. The UK system shows, depending on the hazard and the risk, they gradually introduce some basic one from tier 1, and if required, go to the tier 3, more quantitative assessment. And also, as you are familiar with this FN curves, there's some particularly common law countries adopted this safety requirement using this FN curve. And then also that's as I mentioned, France also has formalized this risk-based approach. Now, when it comes to our client countries, there are some this adaptation needs for using this risk-based approach, because of this technique requires a high level of expertise and the budget, and many countries the data is limited, and also sometimes it could be controversial to discuss the tolerable risk with regard to the number of life loss for this particular dam vis-a-vis other dam and so forth. But we can, as I said, we can also introduce this risk-informed approach, for example, using simplified the risk index in an adaptable manner to our client countries. And the emergency preparedness is also quite important. Many of the high-income countries require owners to prepare this emergency preparedness, but also with varying degree depending on the risk and hazard, and some additional requirements, and also dependent on those factors. I think as Mr. Pandey also mentioned that I fully agree that the emergency preparedness plan first prepared for this really dam failure case, but also quite useful and important for this large amount of flood discharge or gate operation. And I saw that there are some hydropower dams were blamed to discharge too much water during floods, but they may just follow this operational rules. So it's quite important to discuss and define the gate operational procedures and the downstream warning procedure, depending on the incoming water level or the level water level and so forth. This would give just more good preparedness for downstream communities, particularly in charge of flood management. And so this way, just the emergency preparedness is not a really remote plan that typically, put on the shelf, but rather more effectively utilized, and then just, animates all the key stakeholders, including disaster management agency, downstream the communities, and so forth. One thing is as you know, this Oroville Dam, the independent forensic team issued a report, and generally, they're quite top-notch experts here from the ICO, so we can hear about their views about the report. But I would like to draw the attention about the emergency preparedness effectiveness. They prepared this EPP based on the scenario of the breach of the main embankment, and then just ordered evacuation order for around 200,000 people. But maybe this more different scenario, more the targeted evacuation could have been done. Overall, this evacuation, I believe, has been orderly done. So better. The BC Hydro prepared this life safety model, or this University of Utah life sim model, or something so more dynamic, advanced model could be used in the case of advanced countries. I'll go very quickly. The funding mechanism, there is regulators funded by government budget, or from users' payments, or mixed approach, and users' payments can be done in the form of licenses, permits, or auditing fees, inspection fees, and so forth.
Kindly conclude.
Yes, I'm just coming, just 2 slides. I'm sorry for what we were trying to formulate at the end of this exercise is some sort of, decision support tool for enhancing dam safety framework. Different countries have different deterministic characteristics. As I said, legal system, laws administration, portfolio characteristics that you cannot change. But you can also propose the suitable elements based on the deterministic characteristic, including legal form, classification system, regulatory content, and so forth. And again, depending on the size of the portfolio or type of portfolio, we need to see some evolution of the regulatory framework. As you have more dams in the same basin from different sectors, you need to develop the more comprehensive, intensive regulatory framework. This is the last slide. So from this exercise, our experience, the legal framework is quite important to define the role and responsibility between relevant entities. Institutional arrangement should be properly established with sufficient oversight mechanism, and also human financial resources. Dam classification system is useful, particularly with reference to risk and hazard. Compliance monitoring system is also established, and there's including some benchmarking procedure. Risk-informed approach could be quite useful in an adaptive manner to the country's context. And financial mechanism also quite important to sustain the regulatory framework. Thank you very much for your attention.
Thank you, Mr. Oida, for a very exhaustive presentation on a regulatory framework for dam safety. Now, I would request Dr. Martin Weiland, Chairman ICOL Committee on Seismic Aspects of Dam Design, Switzerland, to make his presentation on dam safety, maintenance, and long service life, the main technical factors of sustainable storage dams. Dr. Martin Weiland.
Okay, Mr. Chairman, thank you very much for your introduction.
I would request if you can kindly make your presentation in about 15 minutes.
Yeah, I will,
already we are over the time.
Yes, I know usually it is quite unpleasant to be the last speaker when the others have taken the time up. Okay, I will try to do that. It's a pleasure for me to be here again. I was in India already in December, and I have had a chance to give a presentation here. So my presentation has a relatively lengthy title. I was asked to address several issues, and I would like to say first a few words about sustainability in terms of sustainability, we could consider two aspects. Number one, technical aspects. The second group would be non-technical aspects. Usually in the press you hear about mainly the non-technical aspects. Here I'm talking about the technical aspects, which include dam safety, aging, service life and maintenance. And that is basically the title of my presentation, just to give the overview on what I'm talking about. So I will talk about on the technical issues. Here, this is the oldest concrete dam in Europe. It is located in Switzerland. It was built in 1872 in a pre-electricity age. It is 146 years old and it is still in operation. Okay, so what do I want to say with this example? If we have a well-designed and well-constructed dam, it can survive for a very long time, and this will be in operation for additional decades. Of course, at the time when it was built, the design criteria were quite different from those today. So therefore, for example, there has been a new spillway, there have been some new seismic safety requirement which required installation of rock anchors in this dam to satisfy today's requirement. Our requirements are that any dam, new or old, should satisfy the current safety requirement, which is quite a far-reaching demand. So let me say a few words about dam safety. It was already mentioned at the beginning. Usually in my presentation I expand this kind of, let me say, integral dam safety concept. It includes structural safety, dam safety monitoring, and I've given as a separate issue here operational safety, because you must have qualified staff who are operating your plant, otherwise you are in trouble. And number 4, it was mentioned already a couple of times, emergency planning. In our case, emergency planning means actually alarm systems. This, if we talk about safety, we design for different hazards. Typical hazards from a natural environment are flood hazard and seismic hazard. This is an example taken from Myanmar from 2015. It came a very heavy rainfall and the dam was just being finished, and you see this is an ungated spillway which are considered as actually safe. Nothing should happen. But as you see, during high intensity rainfall, a lot of floating debris basically blocked the ungated spillway. Fortunately, there were still, the dam was not 100% finished, so there was equipment there to remove somehow some of these logs. Because as you see here in this intense rainfall, the dam was close to overtopping. It was an embankment dam. You see it is absolutely full. So they were very fortunate at that time that they had actually this equipment still on site. It's a big dam. Okay. Another example is on the maintenance, on the proper maintenance of, let me say, outlets for flood control. This is a dam in Ethiopia. You can see we have basically 5 openings. We have a low-level outlet on the left, and we have 4 spillway gates. Here, 3, let me say, outlets out of 5 outlets were blocked. Okay, it is a concrete dam. It has also an embankment dam as a saddle dam. It is quite critical in designing flood control. You may know about this N-1 rule, but we see here in this example, we had already N-3. Besides natural environment, okay, hazards from natural environment, we have, of course, the hazards from a man-made environment. This is an example from a German dam which was destroyed by the British Air Force during World War II, and you see it created a 2.5-ton bomb, created a big niche in this masonry dam. Let me say quickly a few words about my committee. It was already mentioned by Mr. Schleiss. Okay, the technical committees are preparing guidelines, and this here is just a list of guidelines which I've prepared by my committee. I have been chairman already for almost 20 years of this seismic committee, but I would like to mention one case. In India, you are very sensitive about what we call the Koyna case, the reservoir-triggered seismicity. We have published a guideline, or it's not a guideline, it's a state of knowledge on the reservoir-triggered seismicity. In the meantime, there have been over 100 reservoirs where some level of reservoir-triggered seismicity has been observed. We don't think it is such a big problem if you follow modern design concept. I would also like to use this opportunity. These ICOLD guidelines, it is quite important that you have access to these guidelines. So since there is a large number of participants here, I would strongly recommend you to become a member of the Indian National Committee on Large Dams, because if you are a member of that committee, you have free access to this about 160 or 170 guidelines which have been prepared or published by ICOLD. It is very important, so please, I think the gentlemen from the Indian National Committee are here. Please apply for membership. It is very useful. Now let me say something briefly about the seismic hazard. Okay, the important issue I would like to address here is the seismic hazard is a multi-hazard. Please keep that in mind. If I talk multi-hazard, it includes, number one, ground shaking, number two, fault movements in a footprint, or we can have some discontinuity which could move during nearby, could be activated during nearby strong earthquakes. We can have fault movements in the reservoir, and basically what has been overlooked in mountainous regions, I would say almost worldwide, are mass movements, basically rock falls into a reservoir and rock falls at the dam sites. And then there are other issues, site-specific issues, deformations, liquefactions, and so on, which I'm not addressing. This is just an example of a dam we have finished. It's the Rutpar-Lorestan Dam. It's a 156-meter high rockfill dam. It is located in a narrow canyon, but in this dam we have actually multiple fault, multi-directional fault in a footprint. We have very high seismicity of about 0.75 G, just to give you some impression. And we have, because the mountains are very steep, we have a high rockfall hazard. Okay, so we have at difficult sites, we have this effect of multiple hazard, multiple seismic hazard. It is not just ground shaking. Most design codes are basically only looking in the ground shaking. It is too limited. We have always been very much against this one-dimensional approach. Okay, this is an example from construction of a dam, how you could proceed, how you could cope with dam in very narrow canyon. You know, the aspect ratio, dam length, crest length to dam height is about 1 here. So we need special design measures rather than the analysis to cope with all these features, fault movements, strong ground shaking, arching effect, and so on in such a difficult location. This shows you about flaring, for example, of a fine sand filters. So let me say something briefly about the lifespan of dams, because dam safety is one important component for sustainability. The other is, of course, lifespan. Okay, very often some people is asked, what is the lifespan of a dam? Nobody knows. Okay, basically we would say the number one issue is safety, so we could say the lifespan of any dam is as long as it is technically safe and operable. It is not 50 years. It can be very short, but it can be hundreds of years, as a case which was mentioned in Marib in Yemen. Okay, what does it mean, the safety? Basically, the requirement that somebody can ensure safety is maintenance. I would say the core issue is maintenance. I have been in quite many countries and I have seen people are neglecting maintenance. And probably maintenance is also, it is basically quite difficult to get the funds, but it is quite important because we can say the lifespan of a dam is as long as somebody takes care of a dam. That means that somebody provides regular maintenance. So proper maintenance controls the economical life of your project. So it is very essential. I must say in Switzerland, the dam owners are only interested to extend the lifespan of their dam project these days. Okay, this is the case of Inguri Dam. This was the world's highest arch dam a few years ago. Okay, the Inguri Dam, basically when Georgia separated from the Soviet Union, there was a civil war, and basically the equipment was looted, and some galleries were flooded, and there was no idea about the performance of the dam. So this dam was quite young at that time, but within a short period of time, actually nobody knew if this dam was still safe. So we could say even after 10 years, if nobody takes care of your dam, it can become unsafe. It does not just stay safe forever, as any people may think. Okay, some factors affecting the lifespan of dams are, of course, changes in design criteria, changes in methods of analysis, results of risk assessments, aging effects, and sedimentation. Okay. Aging, okay, means, for example, in the hydromechanical equipment, we have biological growth, we have a corrosion, we have a seal leakage, we have a lack of maintenance, so the corrosion processes we know are accelerating exponentially. This is a picture from a dam. It's a 250 high meters Mauvaisin Dam. I just like to show it. It was taken when it was 50 years old, and you see it is at a location of about 2,100 meters. So the concrete looks quite fresh. If you look in some other countries, the concrete after 2 years looks already black. Okay, it looks because of its climate. Okay, this is another dam built in the 1930s with a high water cement ratio. This is not the masonry dam like here in Kerala. Here we have only the masonry is a surface protection for frost protection of a concrete. But here we have a concrete with high water cement ratio, which has a very high permeability, and we have this leakage. So maybe here, this is an example of the biggest dam in Turkey, Atatürk Dam. It had to be fitted, it is very big. It is one of the biggest embankment dam, and it had to be completed in a short period of time, because it had to be inaugurated by the president at a given time. The result was that shortly after completion or after inauguration, the dam crest deformed substantially, requiring removal of the top 15 meters of the dam. So it was already an aging process, because if the quality is not done properly, it is an expensive exercise, because the length of the crest is about 1,600 meters. And as a last issue, let me say something briefly about risk analysis. You know, risk is equal probability of dam failure and multiplied with consequences. In Switzerland, if I may use this comparison, we say we have some design regulations which somehow give some value on the probability of failure, but our emphasis is, okay, if you want to reduce the risk, you can work on the probability of failure and on the consequences. The Swiss system is we only work on the consequences. Okay, this is just some example. This is the consequences due to the failure of the dam in Germany, which I've shown earlier, which was destroyed during World War II. Gave a huge consequences. The other picture I just was there recently is in Vaillant. You know, in Italy, where a big landslide into the reservoir has caused a major overtopping of over 100 meters of a dam crest, which causes these issues. So basically, our concern is, let me say in Switzerland, is to work on the consequences. Okay, so to come to the conclusions, I have 3 conclusions. One is economical life of dams. Lifespan, please keep that in mind. If somebody asks you, lifespan of a dam is as long as it is safe, it is clear, and it means as long as proper maintenance can be guaranteed. It is very essential. If nobody is in charge, they will become unsafe very quickly. Benefits of dam safety projects is a big issue, let me say, because financing, because if you do maintenance work, you cannot translate it in additional kilowatt hours. Okay, the economists like to see some increased output, so therefore it needs quite some understanding of the people in charge of the budgets that they provide the proper budgets for maintenance. And I've said maintenance is the key issue. And let me say the last one, dam safety and risk analysis. For dam safety, we use a very sophisticated, actually, dam safety concept, including structural safety, dam safety monitoring, operational safety and maintenance, emergency planning. Okay, so thank you very much.
Thank you, Dr. Martin Weiland. So with this, we come to the end of the presentations. We can have now the questions from the 4 eminent experts who had made the presentation. If there are any questions or observations on these 4 presentations.
We would
Yeah,
request all the speakers to please come over to the dais.
I would request Mr. Pandya, Dr. Anton Schelles, Mr. Oida and Dr. Martin Weiland to just come over the stage so that it would be a better interaction.
Members of the audience may please raise their queries or suggestions. You have your mics here. You can make use of the mics here.
Yes, Dr. Jain, please.
This is to Dr. Sodaro. Sodaro. Hello? Sir, in developing countries, you said there is a data crunch or data deficiency of disasters. And that is a major hurdle. What is the way out? Data deficiency of disasters or data crunch is a major hurdle in informed decision making, in a risk-informed approach.
Can you please introduce yourself also so that the audience comes to know about you?
I am S. Shashidhar, a science columnist.
Question is, if there is a lack of data, what do you do about dam safety? Is that the question?
In developing countries, the major hurdle before making informed risk analysis, data crunch or data divisions. What is the way out?
So basically his question is, in developing countries, there's crunch of good data. So how do you go forward? How do you make decisions?
If I may start, I think from our experiences, we have experienced quite a number of challenging projects where the hydrological data is very limited, just say for 10 years or so. It's very difficult to conduct a proper hydrological assessment with such a condition. Of course, there's experts with advice from the panel of experts and so forth that tries to collect other sources of information from the more overall region or some this envelope curve method when it comes to this big floods, and also checks this, some historical records and so forth. But at the same time, we also trying to help the countries to institute this monitoring system, try to develop, this more enhanced hydromet monitoring system. And of course, we need to wait for some time to accumulate good data. But with their advice from their, supplementary methods that tries to fill the gaps. But I have to admit, it's quite indeed challenging.
Yeah, I mean, please identify yourself and also please indicate whom your question is directed.
My name is Sharad Jain. I am Director of National Institute of Hydrology. This is a small observation addressed to Pandya Sahab. From your presentation, it appears that more than half of our flood storage regulation is coming from rockfill dams. So do you think this should be a factor when we develop reservoir regulation policies? And if yes, then how our regulation policy should be different from flood control point of view for concrete gravity dams as well as for rockfill dams? Thank you.
No, as far as the flood risk is concerned, the risk is largely dependent upon the catchment characteristics and not exactly on the type of the dam. However, as far as the operational policies are concerned and the operational preparedness is concerned, especially I was more focusing on the operational preparedness. Because in case of an operational preparedness or operational failure, the risk to a earthen dam or a rockfill dam will be much, much higher than what will happen to a concrete or a masonry dam. So from that angle, it translates to the fact that the operational staff that has to be posted and the decisions who are to be, the decision makers who are to really take decisions on operations of the dam are something where a different level of preparedness has to be specified. Because we are dealing with a situation where if it goes out of control, we have very little to really remedy it. That was the concept. Yeah, thank you.
Yeah, any other? Yeah, Mr. Gopalakrishnan.
To President Aikol Anton, I wonder what the world is trying to do in case of series of dam in a particular river basin and the revision of the flood hydrology. Most of the upper dams comes later and they are designed for a higher flood insulation, while the lower ones are not being done. And in this hydrologic review, there comes a conflict that all the dams are not uniformly insured towards safety as per the current day revision of floods. How do you go about it? Any guidelines, especially in countries like Brazil? Europe may not be as severe a problem, but where we have this phenomena of severe monsoonic floods and other things, we face some difficulty. Yes.
Okay, dam safety, of course, is related very closely to the local environment, but the general guidelines, as Dr. Wieland presented, they are applicable everywhere. Okay, you have, in many regions, you have different natural hazards, and you have to deal with these natural hazards on a local way. But at the end, let's say the concept of dam safety, all what you have to be prepared, okay, starting from technical safety, then operational safety, then of course the observation, and then finally the emergency planning. So that's, I think that's a worldwide concept. And there was mentioned what we are doing if we have not enough data. I mean, today there is a lot of possibility to get data, perhaps not at the proper location, but there is a lot of data available which are can be applied similarly to a location where there is not enough data. I just say that today we have a satellite where we can bring out a lot of data of this satellite if we can just calibrate them locally, and these are useful tools, and I think in future we will have much more data also from remote sensing, and I think that is not really the problem. The problem is that we use of everything which is available, even if at the proper location perhaps nothing is available, but we can learn from data which is closely related also to a local situation.
I think we can have one more question because we are already running over time. Yeah, please introduce yourself. And, to whom?
I'm Professor M.L. Sharma from Earthquake Engineering Department, IIT Roorkee. My question is to Dr. Martin. As you have well said that these hazard values, they are always changing with time. It is a dynamic system. So what do you think should be the review period, and how often we should go for such exercises to re-evaluate the hazards, knowing that some of the hazard values are having very long return periods?
Okay, thank you very much for these important questions. I have shown this example for a dam almost 150 years old. It is clear that during this very long lifespan, there are several safety evaluations necessary. And these evaluations are necessary, for example, as I mentioned, if you have new design criteria, maybe seismic design criteria. All the old dams have been designed with a pseudostatic approach, which we think is obsolete today. Today you have to take into account the dynamic characteristics. That is one issue. The other is, in the past, the seismic hazard was characterized by a seismic coefficient typically of 0.1, probably also in the Himalayas in India. If you do a site-specific seismic hazard analysis, you get high values, I would say 0.5. I'm involved in a project in Pakistan. We have 1.25 G. You know, it's a very high value. So once we have additional information, I would say then there would be a need actually to do such a kind of reassessment.
I think we can conclude the question answer session because otherwise we will continue and the lunch session is waiting. So I would say that we had four very interesting, exhaustive and illuminative presentations by four eminent experts who are with us. Dam safety is a very serious business. Dam owners, they have a very high responsibility for ensuring safety of the structures. We need to invest in dam safety through trained manpower and required funds. And we have to really carry out the real work of dam safety by practicing the guidelines, the procedures and protocols in respect of the dam safety. So I think with these words, I would give it to my co-chair to make his observations and remarks.
Thank you, sir. The session was very good. We had top four professionals. One is top professional in India, Mr. A.B. Pandya, who was former chairman of CWC. Now he's Secretary General of ICID. And then we had the president of the ICOLD, the president of the seismological part of ICOLD, and finally the chief of water resources from the World Bank. There could have been no better panel than this to start the plenary session. I would request you to kindly give a round of applause to all of them. No discussion is ever complete, but I think all of you, after a lot of food for thought, must be looking for food for your stomach also. So we cannot postpone that. You can carry on your conversation and discussion with the four panelists during the lunch hour. And also they are staying here, you can carry on your conversation during the evenings. So I wish, I thank the panelists and I thank you also for maintaining excellent discipline. And now we have a small ceremony. Kindly over to the lady over there.
Thank you, sir. As a token of our respect and heartfelt gratitude to the distinguished speakers, let's present mementos to them. I would request the chairman of the session, Shri S. Masood Hussain, to present mementos to Shri A.B. Pandya. To Professor Dr. Anton J. Slice, to Mr. Satheru Uda, to Dr. Martin Wieland, may I now request the chairman to present a memento to the rapporteur, Mr. Gulshan Raj. Memento to Mr. Gulshan Raj. And finally to the co-chairman. Finally, to the co-chairman of the session, Shri Sanjay Kundu. I would now request Dr. Martin Wieland to present the memento to the chairman of the session, Shri S. Masood Hussain. Dr. Martin Wieland will now present the memento to Shri S. Masood Hussain. So with these deliberations, exchange of ideas and interactions, we now come to the end of the plenary session, a group photo session. Ladies and gentlemen, let's now break for the lunch. Kindly assemble back after 30 minutes for the post-lunch session. Let me once again remind you, your lunch coupons are in your delegate pass. You can find your lunch coupon in your delegate pass.